Hi everyone, and welcome to our channel. Are you tired of manually watering your plants or worried they aren't getting the right amount of moisture? Well, today we've got a fantastic DIY project for you. An automatic irrigation system using an Arduino Uno, a soil moisture sensor, and a small water pump. It's a simple, effective, and fun way to keep your plants happy and healthy. Stay tuned, and we'll show you exactly how to build it, step by step. So, what magical parts do we need for this project? It's simpler than you think. First up, the brain of our operation, the Arduino Uno. This is a microcontroller board that will program to make decisions. Next, we have the soil moisture sensor. This nifty sensor will tell us how thirsty our plant is by measuring the moisture level in the soil. It has two probes that go into the soil and a small module that processes the reading. Then, we have a small DC water pump. This will be our automatic waterer, delivering water to the plant when needed. We're using a submersible one for this project. We'll also need a relay module, optional but good for controlling the pump. Safely if it draws more current than the Arduino can handle directly. For very small pumps, direct connection via a transistor might also work, but a relay is a common and safe approach. This acts like an electrically controlled switch. Of course, we'll need some jumper wires to connect everything, a breadboard for easy prototyping, a power supply for the Arduino, like a USB cable or a battery pack, and a separate power supply for the pump if it needs more power. Don't forget a container for water and, of course, your potted plant. So how does this all work together? It's pretty straightforward. The soil moisture sensor is placed in the plant's soil. It constantly measures the moisture level. This information, whether the soil is wet or dry, is sent to the Arduino Uno. We'll write a simple program, or sketch as it's called in the Arduino world, and upload it to the Arduino. This program tells the Arduino what to do based on the sensor's readings. Essentially, we'll set a threshold. If the soil moisture level drops below this threshold, meaning the soil is too dry, the Arduino will send a signal. This signal will activate the relay module, which then turns on the water pump. The pump draws water from our container and waters the plant. Once the soil moisture sensor detects that the soil is wet enough, above our threshold, the Arduino sends another signal to the relay to turn off the pump. It's a closed-loop system. Dry soil triggers watering, and wet soil stops it. Genius, right? Now let's look at the connections. The soil moisture sensor has three main pins: VCC for power, GND for ground, and an analog output pin, usually a 0 or SIG. VCC connects to the 5V pin on the Arduino, GND to a GND pin, and the analog output pin to one of the Arduino's analog input pins like a 0. The relay module also needs power, VCC and GND, from Arduino's 5V, and an input signal pin, IN, which connects to a digital pin on the Arduino, say pin 7. The relay then switches the power to the pump. One terminal of the pump goes to the relay's normally open contact. The other terminal of the pump goes to the negative of its power supply. The common COM terminal of the relay connects to the positive of the pump's power supply. Make sure your pump's power supply is appropriate for the pump. All right, let's talk about the code. Don't worry, it's quite basic for this setup. We'll use the Arduino IDE integrated development environment to write and upload our sketch. First, we define the pins we're using. For example, the sensor pin is A0, and the pin to control the relay, and thus the pump, is digital pin 7. We also need a variable to store the moisture value we read from the sensor, and another variable for our threshold. This threshold is the critical value. If the sensor reading goes below this, it means the soil is dry and we need to water. You might need to experiment a bit to find the perfect threshold for your specific soil and plant. In the setup function, which runs once when the Arduino starts, we'll set the pump control pin as an output. We'll also start serial communication so we can see the sensor readings on our computer. This is super helpful for calibration. In the loop function, which runs over and over again, we first read the analog value from the soil moisture sensor. Then we use an if statement. If the sensor value is below our set threshold, meaning it's dry, We send a high signal to the pump control pin, which turns the pump on. Else, meaning the soil is moist enough, we send a low signal to the pump control pin, turning the pump off. And that's the core logic. We'll also print the sensor readings to the serial monitor so you can see what's happening in real time. Okay, the moment of truth. We've got our components connected and the code is uploaded. Let's see our automatic irrigation system in action. So, what are the benefits of this system? Consistency. Your plants get watered regularly and appropriately. Water saving. It only waters when needed, preventing wastage. Convenience. No more manual watering, especially great if you're busy or away from home for a short period. Plant health. Prevents both under and overwatering, leading to healthier plants. And you can customize it too. You can adjust the satchel threshold value, in the code for different types of plants or soil. Some plants like drier soil, others prefer it more moist. You can use a larger water reservoir if you need it to run for longer periods. For multiple plants, you could potentially expand this with more sensors and pumps, though the Arduino Uno has limitations on how many things it can control directly without more complex circuitry. You could also add an LED indicator to show when the pump is running or when the water level in your reservoir is low. That would require an additional sensor like a float switch. This basic automatic irrigation system is a fantastic starting point, but what if you want to take it to the next level? Imagine being able to monitor your plant's soil moisture from anywhere in the world using your smartphone. Or what if you could see a history of when your plant was watered and for how long? Well, that's where IoT, the Internet of Things, comes in. In an upcoming video, we'll show you how to upgrade this project into an IoT smart irrigation system. We'll use a Wi-Fi-enabled microcontroller like an ESP8266 or ESP32, connect it to the internet, and send sensor data to a cloud platform. You'll be able to check the status of the motor, pump, whether it's on or off, and view a history of watering events all remotely. It's going to be super exciting, so make sure you're subscribed and have hit the notification bell so you don't miss out.